Okay, so what we've done so far is create a tree diagram from the scenario. The scenario read, a survey of Stars Mill High School students found that 30% said they'd be interested in going to Jupiter. So that's where we got our first branch. 36% said they want to go to Jupiter, and then that would leave 64% not. Our second branch came from the next sentence. Of those that wanted to go to Jupiter, so I'm going off Jupiter here, 60% were not seniors. So if 60% were not seniors, that left 40% that were. Of those that did not want to go, so I'm going off this bottom branch, 30% were seniors, 30% seniors, 70% not. So then we took the information from the tree diagram and we found these probabilities, these joint probabilities here. The probability of Jupiter and being a senior, because this senior part was dependent on Jupiter, it would be the probability of Jupiter times the probability of senior given Jupiter. 0.36 times 0.4. Jupiter and not a senior, 0.36 times 0.60. Okay, now let's do the other two. The probability of not Jupiter and a senior would be 0.64 times 0.30, and that gives us 192 thousandths. And then the probability of not Jupiter and not a senior is our largest, 0.64 times the 0.70, and this is 448 thousandths.
Wow.
Okay.
Jupiter, one of his.
All right. So we can fill in this two ways. Senior and Jupiter, 0.144. Not senior and Jupiter, 0.216. Senior and not Jupiter, 0.192. And then this one would be the 0.448. Okay, so those totals, I just add them up. Add them up.
Oh man, I hate adding.
Add them up.
What is that?
And add them up. And we should remember from our two-way tables when we did those relative frequency tables last year that they're going to total 1. Do you remember that?
I do.
Okay. So let's use this information to answer these questions. What is the probability that a student wanted to go to Jupiter? Any student. There's no condition right there. That's that first branch, isn't it? 0.36. A student wanted to go to Jupiter. That would be our total down here, right?
0.36.
Okay. Yes, sir.
Do you care if we write them as percentages, or do you want decimals?
Probability should be written as a decimal once we start talking specifically in terms of probability. Reduced fraction or a decimal. All right. A student was a senior and wanted to go to Jupiter. Senior and wanted to go to Jupiter. Okay, so we have done the math here, right? Senior and Jupiter. 0.144. And we could read senior Jupiter. Ooh, there it is in the chart. 0.144. Okay, probability that a student was a senior. What did we have to do to find a senior? We had to find the seniors that wanted to go to Jupiter and those that did not. And when we add those up, we get the probability that we have a senior. And it's 0.336 from adding those two. Okay. Probability that a senior wanted to go to Jupiter. A senior wanted to go to Jupiter.
Yeah, we just do that.
No, this was a student, was a senior that wanted to go to, This one has a condition. This is our condition. So we got to use that formula. So we're going to do the intersection over the condition. The intersection of the two would be the probability of J and S over the condition, the probability of senior. So Jupiter and senior is 0.144 over senior, which is 0.336. Do you see how we have to use this formula? Intersection over condition. The intersection over the probability of the condition. And this gives us approximately 0.429. Okay, now this one has a condition. This time our condition is that we want to go to Jupiter. We're a Jupiter wannabe. So what is the probability that we're a senior given that we're a Jupiter wannabe? Okay, isn't that actually in my tree diagram right here?
Is it? Yes, it is.
Isn't it 0.40? Senior, given that we're a Jupiter wannabe? Now let's prove that it works with the formula too. So this would be the probability that we're a senior and Jupiter over the probability that we want to go to Jupiter. Okay, so that would be 0.144 divided by 0.36. And guess what this gives us? 0.40.
This is some crazy stuff.
And it's 340.
Wait, what?
Like it's 340.
Oh.
Okay.
They're fun.
All right.
It's 340.
So do we see how to use the tree diagram to find our probabilities, to fill in our relative frequency table? Now, if we have 500 students that were surveyed, how can we fill in this information?
Multiply by 500?
We would multiply by 500. Now, if you didn't have a calculator handy, isn't multiplying by 1,000 and then halving the same as multiplying by 500?
Well, technically, that's just
If we multiplied this number by 1,000, wouldn't that get rid of my decimals?
Yep.
So if I half that, doesn't it make 72? 96, 168.
No, it's not.
So if we take these numbers, multiply by 1,000 and half, it's the same thing as multiplying by 500.
Alright, I think I have a better understanding.
Okay, so let's talk about what's required for tomorrow. What's required is just the back.
Of this one?
Yeah. What you can do is start working on the review, or go back and look at some of those homework assignments we've already done. If there's something you need to look at again, the batch really shouldn't take at most 10 minutes. And that's if you have to spend some time looking for your calculator.
There's like 500 of them. My brother lost